Pressure beneath Campi Flegrei is not easing, and the latest measurements are forcing a reassessment of what reduced earthquake activity actually means. If seismic shaking appears to be declining, why are gas emissions climbing so sharply? Why is the land continuing to rise after a brief pause? And what does it indicate when heat signatures remain persistently elevated across one of the most closely monitored volcanic systems on Earth? These questions are no longer theoretical. They are grounded in a steady stream of observations that, taken together, outline a system still undergoing active change. Campi Flegrei, a vast caldera system situated west of Naples, spans a densely populated region where urban infrastructure coexists with an active volcanic landscape. The broader metropolitan area surrounding the caldera includes more than 6 million residents, placing it among the most closely scrutinized volcanic zones globally. Its history is defined not only by eruptions, but by prolonged phases of unrest, characterized by gradual ground movement, gas emissions, and shifting thermal activity. These phases can persist for years or decades, often without culminating in an eruption, yet they provide critical signals about subsurface processes. Recent data indicates a divergence between surface-level seismicity and deeper geophysical trends. Earthquake frequency has shown an overall decline compared to earlier peaks. But this reduction has not been accompanied by a stabilization of other indicators. Approximately 1 to 2 weeks ago, a localized swarm still occurred, reinforcing the idea that seismic quiet does not equate to system stability. Instead, the broader pattern suggests that pressure beneath the surface may be redistributing in ways that do not always produce frequent fracturing events. One of the most significant changes observed in recent months is the increase in carbon dioxide emissions. Measurements have climbed to roughly 16,000 grams per square meter, compared to about 11,000 earlier in the year. This rise is not marginal. It represents a substantial increase in the volume of gas escaping from the subsurface. Carbon dioxide, unlike some other volcanic gases, can migrate through rock layers more easily, making it a sensitive indicator of deeper magmatic or hydrothermal processes. Elevated emissions often imply that gases are accumulating and finding new pathways to the surface, a process that can occur even when seismic signals appear subdued. At the same time, ground deformation has resumed an upward trend. After a period in which uplift appeared to slow to approximately 1 centimeter per month, recent measurements show a noticeable increase over just the past few days. This renewed acceleration is particularly significant because ground uplift is one of the most direct indicators of pressure changes beneath a caldera. When magma, gas, or hydrothermal fluids accumulate, they exert force on the overlying crust, causing it to expand and rise. Even small increases in uplift rates can reflect substantial changes in subsurface conditions. This process, known as bradyseism, has been a defining feature of Campi Flegrei for decades. Since around 2005, the ground has risen by nearly 1.8 meters, a cumulative change that is both measurable and visible. In Pozzuoli, areas that were once submerged beneath seawater are now exposed, with vegetation beginning to take hold where marine conditions previously dominated. Such transformations are not merely cosmetic. They reflect long-term shifts in the balance of forces beneath the surface. Bradyseism is driven by complex interactions between magma and hydrothermal systems. As fluids heat up and expand, or as gases accumulate, they create pressure that pushes the ground upward. This process can occur gradually, punctuated by periods of acceleration or temporary stabilization. The current phase appears to be one of renewed upward movement, suggesting that whatever mechanisms are driving the uplift remain active. Temperature measurements provide further evidence of sustained activity. At fumaroles, where gases escape directly from the subsurface, readings remain elevated. At a distance of about 5 meters from emission points, temperatures reach approximately 95 degrees Celsius, implying significantly higher temperatures closer to the source. In the Solfatara area, particularly at the BG fumarole, average temperatures are around 173 degrees Celsius. These values indicate that the hydrothermal system is not cooling. Rather, it continues to operate at a high-energy state. The Solfatara region holds particular significance because it coincides with the highest concentration of earthquake epicenters within the caldera. This overlap between seismicity, gas emissions, and thermal anomalies suggests that it is one of the most active zones in the system. It is also considered among the more likely areas for potential eruptive activity should conditions evolve in that direction. The alignment of multiple indicators in a single area reinforces the interpretation that processes beneath Solfatara are especially dynamic. An important aspect of the current situation is the apparent change in how the Earth's crust is responding to internal pressure. Under typical conditions, increasing pressure leads to fracturing, which manifests as earthquakes. However, recent observations suggest that the crust may be behaving in a more elastic manner, absorbing stress without producing as many seismic events. This does not reduce the amount of pressure present. Instead, it allows that pressure to accumulate over time. Such a response can create a misleading sense of stability. Fewer earthquakes may give the impression that the system is calming, yet the opposite may be occurring beneath the surface. Pressure can continue to build until it reaches a threshold where the crust can no longer contain it, potentially resulting in a sudden increase in seismic activity or other forms of release. This dynamic complicates interpretation as it requires integrating multiple data streams rather than relying on a single indicator. There is also the possibility that some of the most recent measurements could be adjusted as additional data is collected and analyzed. Minor inconsistencies in instrumentation or environmental factors can influence readings, particularly over short timescales. However, the broader trend remains consistent across multiple indicators. Rising gas emissions, sustained high temperatures, and renewed ground uplift all point toward continued pressurization. Historical patterns at Campi Flegrei provide context for these observations. Periods of accelerated uplift have often been followed by increased seismic activity, sometimes in the form of swarms that can occur over days or weeks. The recent swarm, although limited in duration, fits within this pattern and suggests that the system is still capable of producing sudden bursts of activity even when overall earthquake frequency is lower. A bulletin released on March 18th noted a decrease in earthquake numbers and a temporary slowing of uplift. At the same time, it emphasized that bradyseismic activity had not diminished, largely due to continuously rising carbon dioxide emissions. This distinction is critical. While some indicators showed short-term moderation, the underlying processes driving the unrest remained unchanged. In the days following that bulletin, the situation has evolved again. The renewed increase in ground deformation suggests that the earlier slowdown may have been temporary rather than indicative of a longer-term trend. When combined with the sustained rise in gas emissions and consistently high temperatures, the data points toward a system that is still adjusting to internal pressures. Campi Flegrei behavior cannot be understood through a single parameter. It requires a synthesis of seismic, geochemical, and geodetic data, each providing a different perspective on what is happening beneath the surface. The current phase is characterized by a complex interplay between these factors, with some signals appearing to contradict others at first glance. Reduced seismicity alongside increasing emissions and uplift is one such example, highlighting the need for careful interpretation. The absence of a clear decline in activity is itself a significant observation. None of the primary indicators, gas output, temperature, or ground deformation, show a sustained downward trend. Instead, they either remain elevated or are increasing, suggesting that the system has not entered a phase of relaxation. This persistence is a defining feature of the current unrest. At the same time, uncertainties remain. Volcanic systems are inherently variable, and short-term fluctuations can occur without leading to major changes. Data collected over days or weeks must be evaluated within the context of longer-term trends, which can span years or decades. Even so, the alignment of multiple indicators over recent months strengthens the interpretation that pressure beneath Campi Flegrei is continuing to build. The implications of this ongoing pressurization extend beyond immediate seismic or thermal effects. Changes in gas emissions can alter local environmental conditions, while sustained ground uplift can impact infrastructure over time. In areas like Pozzuoli, where the effects of bradycism are directly visible, these changes are already part of the landscape. As monitoring continues, attention remains focused on how these indicators evolve. The relationship between uplift, gas emissions, and seismicity will be particularly important in the coming weeks, especially if the current acceleration in ground deformation persists. Any further increase in pressure could influence the frequency and intensity of future earthquake swarms, as well as other forms of activity within the caldera. The pattern observed so far does not indicate a system returning to baseline conditions. Instead, it reflects a state of ongoing adjustment, with multiple parameters trending in directions consistent with continued unrest. Whether this leads to further escalation or stabilizes over time depends on processes that are still unfolding beneath the surface, beyond direct observation. The continuation of these trends places increasing emphasis on how the system behaves over short intervals, particularly when multiple indicators begin shifting at the same time. The recent acceleration in ground uplift, observed over just a matter of days, stands out not only because of its magnitude, but because of its timing relative to other changes already underway. When deformation intensifies alongside rising gas emissions and sustained thermal output, it suggests that the underlying processes are not isolated but interconnected within a broader pressurization phase. This relationship becomes clearer when examining how carbon dioxide release corresponds with deformation patterns. Gas accumulation at depth exerts force on surrounding rock, and when pathways open, that gas migrates upward, increasing emission rates at the surface. At the same time, if the volume of gas and fluids continues to expand beneath the caldera, it contributes to uplift. The simultaneous increase in both parameters indicates that the system is not simply venting excess pressure, but continuing to generate it. Another important detail lies in the spatial distribution of activity. The concentration of earthquake epicenters around the Solfatara area, particularly near the BG fumarole, aligns with zones of highest temperature and gas output. This clustering is not random. It reflects areas where permeability in the crust allows gases and heat to move more freely, while also marking zones where stress is more likely to accumulate. When these regions show persistent anomalies across multiple datasets, they become focal points for ongoing change within the caldera. The persistence of high fumarole temperatures reinforces this interpretation. Readings approaching 173 degrees Celsius at the BG fumarole indicate that the hydrothermal system is being continuously supplied with energy. Even measurements taken several meters away from vents, where temperatures remain near 95 degrees Celsius, confirm that heat is not dissipating. Instead, it is being maintained at levels consistent with active fluid circulation and gas release. At depth, these conditions point toward a system where fluids are being heated, pressurized and circulated through fractures and porous rock. As pressure builds, these fluids can alter the mechanical properties of the crust, making it more ductile in some areas while increasing brittleness in others. This uneven response contributes to the complex pattern of seismicity observed, where periods of relative quiet can be interrupted by sudden swarms. The recent decrease in overall earthquake frequency must be interpreted within this framework. Rather than signaling a reduction in activity, it may indicate that stress is being accommodated differently. If the crust is temporarily absorbing pressure without widespread fracturing, seismic output can decline even as internal pressure increases. This creates a lag between the buildup of pressure and its eventual release through earthquakes or other mechanisms. Such conditions are often associated with transitional phases in volcanic systems. Instead of a steady progression toward either stabilization or eruption, the system enters a state where multiple outcomes remain possible. Continued uplift could lead to further deformation and eventual fracturing, triggering new seismic swarms. Alternatively, increased permeability could allow gases to escape more efficiently, moderating pressure without significant seismic escalation. The current data does not clearly favor one outcome over the other, but it does indicate that the system remains far from equilibrium. Ground deformation data provides one of the clearest indicators of this imbalance. The cumulative uplift of nearly 1.8 meters since 2005 represents a long-term trend that has not reversed. Even during periods of apparent slowing, the overall trajectory has remained upward. The recent increase in uplift rate suggests that whatever mechanisms briefly reduced deformation have been overcome by renewed pressure at depth. In Pozzuoli, the visible effects of this uplift continue to evolve. Shorelines have shifted and areas that were once underwater now remain exposed. Infrastructure in these zones experiences gradual but persistent change as foundations adjust to the rising ground. While these shifts occur over extended periods, their cumulative impact becomes more pronounced as uplift continues. The interaction between ground movement and gas emissions also has implications for how pressure is distributed within the caldera. As the surface rises, fractures can open or widen, altering the pathways available for gas escape. This feedback loop can either relieve pressure locally or redirect it to other parts of the system. The result is a dynamic environment where conditions can change rapidly over relatively small distances. Short-term fluctuations in data must also be considered carefully. Measurement systems, while highly precise, can be influenced by environmental factors or calibration adjustments. However, when multiple independent indicators point in the same direction, the likelihood that observed trends reflect genuine subsurface processes increases. In this case, the convergence of rising emissions, elevated temperatures, and renewed uplift strengthens the interpretation of ongoing pressurization. The timing of recent changes is particularly relevant. The bulletin issued on March 18th noted a decrease in seismicity and a temporary slowing of uplift, yet emphasized that bradyseismic activity had not diminished due to continued increases in carbon dioxide emissions. The subsequent rise in deformation, observed in the days following that report, suggests that the earlier slowdown may have been part of a short-term oscillation rather than a sustained shift. This pattern of temporary stabilization followed by renewed activity has been observed in previous phases of unrest at Campi Flegrei. It reflects the complex balance between pressure accumulation and release within the system. When one mechanism temporarily reduces stress, others may continue to build, eventually restoring the upward trend. The possibility of another earthquake swarm remains consistent with these observations. Historically, periods of accelerated uplift have often preceded increased seismic activity. While the exact timing of such swarms cannot be determined in advance, the conditions currently present are aligned with those that have led to similar events in the past. At the same time, the absence of a clear downward trend in any major indicator underscores the persistence of the current phase. Gas emissions remain elevated, temperatures continue at high levels, and ground deformation shows renewed acceleration. None of these parameters suggest that the system is returning to a baseline state. The broader implication is that Campi Flegrei remains in a state of active unrest, with multiple processes operating simultaneously beneath the surface. The interaction between magma, hydrothermal fluids, and the surrounding crust creates a system that is both responsive and unpredictable. Changes in one parameter can influence others, producing complex patterns that require continuous monitoring and analysis. As new data continues to be collected, attention will remain focused on whether the current trends persist, intensify, or begin to diverge. The relationship between seismicity and deformation will be particularly important, especially if further uplift is accompanied by a return to more frequent earthquakes. Similarly, any continued increase in carbon dioxide emissions would reinforce the interpretation that gas accumulation at depth is ongoing. For now, the available evidence points toward a system that is still adjusting to internal pressure, with no clear indication of stabilization. The recent acceleration in uplift, combined with sustained high emissions and temperature, suggests that the processes driving the current phase of unrest remain active. If you found this update informative and want to stay ahead of critical developments like this, make sure to like, share, and subscribe. Tap that hype icon to help this video reach a wider audience so more people stay informed about what is happening beneath Campi Flegrei and other dynamic regions around the world.